differentiable at x equals 1. Again, for 58, I already wrote solutions, and I'm going to post them. You're not responsible for that problem anymore. But I'd like to talk about it quickly. So what is important 100% is the definition of continuity at the point. Anyone would like to tell us what it is? It's okay if you're wrong.
It means that you can follow the whole graph with your pencil without
Right,
moving
but the formal definition of continuity at the point. Absolutely. This is continuous. Correct. But what is the definition of continuity at the point?
That x equal 1 exists on the graph. And
Careful, careful. Let's review this. The limit of the function as x approaches 1 from the left must equal the limit of the function
of x equals 1 from the right.
as approaches 1 from exactly.
So the limit
And
of f of x,
and
x equals 1.
But there are three things. We must have three things. Equals,
the function of 1.
exactly. Absolutely. So yes, Brendan, you wanted to say something? Go ahead.
Oh no, I was just gonna add on. I was gonna say one, but I also just meant so basically when it equals left and the right, limit f of x, and then x equals 1 from both points, that would exist.
Right. So if all these exist and are the same, so this will be from x cubed because it's from the left, and this will be from 3x minus 2 because it's from the right, and of course this will be from the left because it's x equals 1, and here is where I have equals. So this will be 1 because I plug in 1 to the third. So this limit as x approaches 1 from the left from x cubed must equal, and I don't know, that's the definition, so I don't know, we'll see in a moment, as x approaches 1 from the right from 3x minus 2, and let's see if this equals 1. What does this limit equal to?
1.
Exactly. What does this limit equal to?
1.
1. And this is 1. All three things. So please remember the definition of continuity at a point has three pieces, and they have to be the same. Okay, next. So this is done, of course. Continuous at x equals 1, not 4. Good. So now differentiability, this is a little bit more difficult because I have to find the derivative of x cubed. Okay, so I have to find g prime. I have to find the derivative of x cubed. And I have to find the derivative of 3x minus 2 when x, notice, just less than 1 for now, and x greater than 1. And I don't want to spend too much time on this because we're going to do this right now. I'm going to start with the differentiation rules. So allow me to just give you the answer. So then g prime you'll see equals 3x squared. Just trust me for the next 3 minutes. With x less than 1, and this is 3 for x greater than 1. Because the limit from this, as x approaches 1 from the left, we'll see yes or no. Limit as x approaches 1 from the right. If these two are the same, then we will conclude differentiable at x equals 1. So what is this limit?
Three.
Excellent. What is this limit? The limit of a constant is the constant itself. So they are the same, and I will say yes, differentiable at 1. Okay. So that was a remainder from last time, and now I would like us to, this will be easier now because we are going to look at differentiation rules 1.5. Differentiation rules. Okay. So first let's let's identify the fact that f prime can be rewritten as the derivative of y or f is the same thing, with respect to x. Okay? So this is a notation. This is a different notation. This is called the Leibniz notation. Yes, this has a significance by itself, and this has a meaning by itself as well, but together represent the same thing, a different notation. Sometimes we will use this notation, sometimes we use this notation, same thing. So the first rule is the power rule. The power rule says that when we have x raised to a power, any power, it's n prime, the derivative, we get, bring down n and subtract 1 from the power. To be exact, I should write times x prime times this prime. We do not need to. No need. Why? Because x prime is 1. What am I asking here? If I have y equals x, what is the slope of this line? What is the rate of change, in other words?
1.
Exactly.
The slope is 1.
Exactly. Exactly. So that's why there is no need, but please keep in mind, because very soon we're going to get to a different formula in which we have a function here, but then that will not be 1 anymore. Okay? So that's the power rule.
Just to clarify that real quick, is that the letter N as in no?
S, yes, it's N as in no. So this is my N and this is my M.
I was pretty sure they were cursive
No,
ones like that,
but
but I was like, let
yeah,
me just double check because
absolutely. Sorry about that. Okay, so that's the power rule.
So it is an n?
It is an N.
All right.
Any power. Just put whatever you want in there. Okay. So then the derivative of a constant, power, the next differentiation rule, a constant prime.
Professor Lead,
Yes?
is that what you want us to turn in for the work today, the power rule? Because we're going to be working on that.
No, not yet.
Okay.
We're going to look at problems in a minute, but thank you so much. So
Okay,
what is the rate of change of a constant? You have $10 in your pocket, nobody gives you anything, and you're not getting anything, you're not giving anything. So what is the rate of change if you don't do anything to $10?
0.
Of course,
0.
of
Okay.
course. No rate of change. There is a constant, yep. A constant times a function. The same thing when we had the limit, right? I could put the constant in front, the same thing. C times the function prime. Now, if I have a sum of two functions, that's all I have to do, f prime plus g prime. What if I have a difference? Same thing. F minus g. Okay, that's it. So if you'd like to open on page 154, and we're going to practice this. Okay. I'm choosing problems as similar as possible to the ones you have to work on, so I make it as easy as possible on you, and I hope you're going to redo the notes first. That's my hope always. So let's look at 25. And we have y equals 1/2, and x is raised to 4/5. There are not too many nice problems in this book, to be honest. So this is a constant times a function, right? 1/2 times x to 4/5. So the constant, so I can write y prime, I can write f prime of x, I can write dy over dx. All these mean the same thing, the derivative of this function. It's a function that gives the instantaneous rate of change at any point where the function is differentiable. It doesn't have a corner, a jump, vertical tangent, etc., etc. So I have 1/2. I will bring down 4/5. Copy x and subtract 1 from the power. And this is the power rule. I brought down the power, I subtract 1 from the power, and there is no need to differentiate this because the x prime is 1. Okay, so then I multiply, not before I simplify. So this is 2/5 in front. 4/5 minus 1, again 4/5 minus 1 over 1, the least common denominator is 5, and you need to multiply this by 5. So 4 minus 5, negative 1. So then x raised to negative 1/5. You can rewrite it if you wanted to as 2 over 5, the 5th root. We reviewed these properties, the 5th root of x. Yes, you can also rationalize, but this is good enough for now. Stop me if you have questions. Do we understand these steps on this problem? Anyone? Okay, 35 then. Same page, 154. So for this function, 2 over 5x to the 6th, always remember, factor, simplify. These are the key words in math. I don't like this presentation. I can do whatever I want as long as it's legitimate. I want this. That's why we reviewed those exponential rules, so we can manipulate and make our life easier. I manipulated this function and changed it from what it was into 2/5 x to negative 6. Why? So much easier to differentiate. So I simplified the function the way I pleased, as long as it's legitimate, of course. So then f prime of x, I bring down negative 6, so this becomes negative 12/5, negative 6 times 2, times x to negative 6 minus 1. Now, if you want, you can go back. But I will not work on the function as is or differentiate it as is, because there is another option that is much easier. Now, I would like us to, moving forward, to carve in stone one thing for now. There are other things. But for now, I would like to carve in stone the following. Let's say we have a function that is 1 over x. Who cares? You're going to say. Change it into this. Yes, of course I will. And let's find its derivative. Can anyone help with this derivative?
Minus 1 over x
minus
to the second power.
X to negative 2. Correct. Very good. So now, moving forward, I would like us to note and remember this, so we don't have to explain it again. Can I? Will I? Of course. But this is the easiest thing to remember. Please. Please carve this in stone in your memory. It will save us a lot of time. Okay, so keeping that in mind, I'd like to move to 47. Same page. You are supposed to stop me if you have any questions, please. I'll wait if you have anything for me.
Just to double check with that last note that you made, if say the number wasn't wanted to be like 8, it would still be negative 8 over x squared, correct?
Yes, yes, because a constant will not change anything. So if I put here 8, then I also have to put here 8. The constant will not change anything. Very good question.
So,
Yes? Go ahead, Kimmy.
if that type of question shows up on the test, are you expecting us to show all the work to get to negative 1 over x squared?
No,
Or could we just
that's my
write
next
negative 1?
example. That's my next example. Very good. You're way ahead of me. Awesome. So we're asked to differentiate this. So remember, x over 7 is really 1 over 7 times x. So when you see something like this should pop up in your head immediately. So then I have 1/7 times 1. I don't have to write anything because x prime is 1. But now this is that. So I don't have to waste my time and differentiate this because I already know the rule. 1 over x prime is negative 1 over x squared, and it's done. And there is no need to show anything else. That's perfect, good enough. Any questions? Any questions for me? Anyone?